Now we're going to look at the inverse of the convolution. So I have to do the inverse Laplace transform. If I have the form f of s times g of s, it's going to give me the convolution of f and g, which by definition is 0 to t f of tau times g of t minus tau d tau. So we're working again backwards in the Laplace to the convolution. So the steps to finding the inverse. First, you have to identify what the two functions are. So you have to identify what is your f of s and what is your g of s. Secondly, find those inverses. So the Laplace inverse of f of s, which will give us f of t, and the Laplace inverse of g of s, which will give us g of t. And then lastly, integrate. So back to that definition, 0 to t f of tau times g of t minus tau d tau. So we have to integrate that. Now, the examples that are here, really we could use partial fractions for, but we're going to use the inverse. And you can go back and do them with partial fractions and pull it apart and see that you get the exact same thing. So for my first example, we have 1 over s minus 1 times s plus 4. So the first thing is, what is f of s? Well, that would be the 1 over s minus 1, that first function. And then g of s would be 1 over s plus 4, the second function on the bottom. So we're just pulling them apart. And then we have to do the inverse Laplace. So the inverse Laplace of 1 over s minus 1, well, that's just a is equal to 1, so we get e to the 1t. So that's the first function, f of t. And then for the second one, I'll do it over here, the inverse Laplace of 1 over s plus 4. And here a is equal to a negative 4, so we get e to the negative 4t. And that's our g of t. And now we're going to integrate from 0 to t f of tau, so we get e tau, times g of t minus tau, so that gives us negative 4 t minus tau d tau. So I want to kind of clean this stuff up and remember that we're integrating with respect to tau. So I'd have 0 to t e tau times e to the negative 4t times e to the 4 tau. Well, this e to the negative 4t, we're not integrating with respect to it, so we can just pull that out. And that's going to give us e to the negative 4t times the integral 0 to t e to the 5 tau d tau. Integrate that, I'm going to get a 1/5 out. So e to the negative 4t times 1/5 times e to the 5 tau from 0 to t. So 1/5 e to the negative 4t e to the 5t minus e to the 0, which is just 1. So I end up with 1/5 e to the, I'm distributing this, so I'm just going to get e to the t, and then minus 1/5 e to the negative 4t. And then I have one more. And again, this one you could use partial fractions as well. So we have 1 over s times s squared plus 1. So my f of s is going to be 1 over s. My g of s is going to be 1 over s squared plus 1. Inverse Laplace of 1 over s is just equal to 1. So that's my f of t. And the inverse Laplace of 1 over s squared plus 1 is sine t. So that's my g of t function. So the convolution of f and g is the integral from 0 to t, 1 times sine t minus tau d tau. So when you integrate that, we get negative cosine So when you plug in t into that, you get negative cosine of 0 minus negative cosine of t. So this would give us a negative 1 plus cosine of t.